You can hang out on the couch too if you want.
Thanks.
Okay. Okay, matrices?
Yeah.
Um,
Here.
okay, so let's go generally what it is first. Now, it's just a way to organize numbers, like they're doing here, right? So if this is types of things in the days, you can organize the numbers that way. Okay, so
Here's the way I thought it hard here.
okay, so okay, so let's go over adding, subtracting, and multiplying numbers into matrices. Okay. Rule number 1: you may only add matrices if they have the same dimensions, right? So if it's like 1, 3, 4, and 7 plus 1, 1, 2, and 2, then it's a 2 by 2, then it's totally fine. Now, the dimensions I'm talking about is row by column. Row by column. Okay? So it's a 2 by 2, I said, because there's 2 rows and 2 columns. Okay. So whereas if you try to add these together, you could not, because they're not the same dimensions. This is a 2 by 3. Does that make sense? Okay. Now let's add them together. When you add matrices together, you just add each individual spot together. So let's go over what that means. Here's why. If you want to see, like, this person purchased this and this person purchased this, on the first purchase, the first thing on the top left is the number of leashes. And the first thing on the top left is the number of leashes for the first purchase. So when you add those together, you're going to get the total number of leashes for purchase 1 total for each people. So that's why you have to add each individual spot. So when you get the answer, 1 plus 1, this becomes 2. 3 plus 1, that's 4. 4 plus 2 becomes 6. And 7 plus 2 becomes 9. So to add matrices, as long as it's the same dimensions, you can add each individual spot. Same thing for subtracting. You subtract each individual spot. Okay, let's talk about multiplying by a constant. Multiplying by a number, by a scalar, we call it. You heard that before, scalar?
Yeah.
Let's try this. Multiplying it by 3. Multiplying by 3 is like adding 3 of them together. So it's kind of the same thing as adding over and over again. But it's faster just to multiply it through all the spots. What would your matrix be in the end then?
Okay, so it would be 3, 6, 12, 9.
Perfect. Okay, that's it. So multiplying by a number, I should say, and adding, subtracting, not too hard with matrices. Let's go on to the next thing. Let's try this. That's pretty much the same ideas. Okay.
This is the same thing as that.
Oh, okay. I was just like, how is this any different? Is this just what happened here?
Well, it printed out sideways. So for this one, it printed out sideways, as you can see. 1.
Oh, that's weird.
It was gonna ask this. You printed out this one.
Oh, okay.
Yeah.
All right. So let's go to the next thing,
Yeah.
which is using matrices to solve systems of linear equations. That's probably next. Yeah. Before we go over that, have you talked about multiplying matrices, like one matrix times another matrix, or not yet?
I think so.
Okay.
Can you show an example?
Yes. Let's try this one. Let's do an easy one.
Oh yeah, we've learned.
You have learned this? Okay. How are you with this?
I feel comfortable about it.
Okay, so row by column, row by column, you're talking about? Okay. Make sure that this is a 2 by 2, and this is a 2 by 2. Make sure the middle two match before you can multiply them together.
Okay.
Okay, so if this were, so this is a 2 by 2 and 2 by 3. So can you multiply those together?
Yes, you can.
Yes, exactly. And what you end up getting is the outside numbers. And you end up getting a 2 by 3. Okay. So skip multiplying. How about, have you talked about either like identity matrices, inverse matrices? So that's all you've done so far, just adding, subtracting, multiplying? Okay. So this is the next thing then.
Yeah, it's just the ready, set, go for that one. I've already done this part. I didn't really get this part because I didn't read R2. I mean, I never read row 2, but I wasn't really sure what to place in each line.
Let's go through it. So, first of all, how are you with taking a system of equations and writing the augmented matrix?
I think I could do that well.
Okay, so let's go to that. So I'll just skip that to that. And you just write the coefficients. So we got 3, 2, and then put a line or a dot 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 or something to represent the equal sign, and then 40, and then 1, -7, and -2. Okay, so those are augmented matrix. Now, here's the idea. The idea is to get this to be 1, this to be 0, and this to be 1.
Yeah.
So we want 1's in the diagonal and 0's underneath. Okay, you got that. So first thing I always do is
elimination.
Well, let's go through just making this 1 somehow, and then making this 0 underneath it. Okay, so so one thing we could do is oh, they did elimination. That's different than what I'm thinking of. Well, let's just go through elimination. Okay, so let's follow their logic. -3 times row 2 and replace row 2. That's what that notation means. So let's do -3 times row 2 and replace row 2 with what we got. So we haven't done anything to row 1, so keep that exactly the same.
Let me have -3, 21, and 6.
Perfect. And then we could take row 1 plus row 2 and use that to replace row 2. Because we want this to be 0, not the top. Okay, so that's our elimination. We added those together. Now let me go over a couple rules for these operations. Things you're allowed to do. You're allowed to replace rows, like you can switch them. You're allowed to add or subtract rows. You're allowed to multiply by a constant. That's it. That's the only things you're allowed to do in these operations, these matrices operations. So let's add them together. So we get 0.
If you add 22.
23.
23, yeah. And then 46.
And we haven't done anything to the top, so just leave it exactly how it is.
So you to reduce it?
We do.
Yeah.
So we've got this to be 0. We need this to be 1 and this to be 1.
So divide by 23 on both sides?
Perfect. So in other words, the operation we're doing is 1 over 23 times row 2.
Yeah.
And replace row 2. Or you can say divided by 23 something. So that's the notation for what we're about to do. So then, once again, the top stays the same. Let's just do this one step at a time. And you get 0, 1, and 2. But let's get this to be 1. Well, we can divide everything by 3. So then, let's take 1/3 times row 1 and replace row 1. So then you get 1 and 2/3 and 40/3 and 0 and 1 and 2. Okay. So we could solve it now, because if you think about it, this is 0x plus 1y equals 2, so you know y equals 2. Does that make sense?
You lost.
Let's go back. The whole goal of this operation is to get to a point where we have 1 here, and hopefully zeros everywhere else. So let's pause for a second. There's a couple things we can try. We can either try to make this 1, or we can try to make this 0. Which one do you want to do right now?
I want to make 2 0.
Sure. So then that would be pretty easy, because you can. So then the operation we could do is multiply -2 times row 2, and then add that with row 1. Does that make sense?
Yeah.
And then we'll replace that into row 1.
Okay.
Okay. So Negative 2 times this is nothing. Plus 3 is just 2 to 3. So this becomes 0. This becomes 36. Did I lose you there?
No, we didn't.
Okay. So what does the top become then?
Alright, so it becomes 1 or
Well, so
oh,
let's take negative 2 times row 2, right?
yeah.
So negative 2 times 0.
Oh, this would be 3.
Would be 3 still, yeah?
Yeah. And then that would be 0.
0, okay.
And then the next would be 36.
Very good.
And then below would be 0, 1, and 2.
We're almost there. We're supposed to get 1 and 1 and 0 and 0. This needs to be 1. So what should we do?
Multiply.
Go ahead.
Multiply the second row by negative 3.
Well, all we gotta do is make this 1. There's a fast way of making this 1. How can we make this 1?
Divide by 3.
Divide by 3. Why don't we just divide everything here by 3?
Oh, yeah.
So,
oh, yeah.
So then the operation would be 1/3 times row 1 and replace row 1.
Yeah.
So it's going to be 1, 0, and 12, and 0, and 1, and 2. We're done.
Yeah.
Because now we know 1x plus 0y equals 12. In other words, x equals 12.
Yeah.
0x plus 1y equals 2. In other words, y equals 2.
Okay, I got that then.
So the idea here is do all these operations to somehow get 1 and 1 and 0 and 0 and whatever you're left here is the answers for x and y. Okay. Let me try a bigger one.
Sure.
Let's try 3 by 3. Like this one. Unless there's something else you want to do.
I'd like to work on this page actually.
Okay. Right. Okay. So let's write it as an augmented matrix first. It's going to be 2, 4, 3. So 2, 4, 3, and 37. Now, the biggest and best piece of advice I can give you about what we're about to do, take your time and be very careful. If you mix one little number up or one sign or something, the whole thing is wrong.
Okay.
So just take your time and be careful. So 3, 3, 3, and 33. 3, 3, 6, and 48. Okay. So here's what I like to do. Here's the format. Like there's a process for this. I like to make this 1 first, and then use that 1 to make these other ones 0. So it's up to you how to make this 1. We could take -1 times the first and add it with the second. We could take -1 times the first and add it with the third. I don't think we should divide everything here by 2 because not all this is divisible by 2. So let's try that. Let's try -1 times row 1 plus row 2 and replace that into row 1. Okay, so what would you get on the top then?
So then you get -2.
So let's see, so -2 plus?
Yeah. -2 plus 3.
Which is?
-2 plus 1.
1. That was the point, to make
Yeah.
it 1. Right?
And then that would become -4 plus 3, which is -1. And then -3 plus 3 is 0. And then -3 times 37.
-1 times 37.
Oh yeah, -1, -37, and then 4 will be left over, -4.
-4. Okay, and then everything else is the same. You should only do one step at a time.
Okay.
So we got this to be 1. Now we can use that to get either of these to be 0.
Okay.
So which one do you want to make 0 first?
The second column.
The second one. So let's do. So let me ask you, how can we make this to be 0?
Well, you could divide by 3. Well, that become 1. But you can multiply the top by -3. And then add that to the second row.
And then put it into?
Put it into row 1 or row 2.
Row 2.
Yeah.
Exactly. Put the result in row 2. Okay.
So it becomes 0,
Well, let's just...
Yeah, -3 plus 3 is 0.
Sorry, let me just finish this. Okay, yep. And then 0.
Yeah. And then 6.
Yep.
And then 3.
Uh-huh.
And then 21.
Well, it's -3 times -4, right?
It's 12, and then
Plus
so
row
30
2.
plus 33, 45.
Yep.
And then 3,
This is all the
3,
same.
6, 48.
Alright, so 1, 0. Now we need this to be 0. So what are we going to do to make that 0?
You can multiply the first column by -3.
Very good.
And then add that to row 3.
Uh-huh.
And then put it in row 3.
Very good.
So it would become -3 plus 3 is 0.
Okay.
Then -3, they become 3 plus 3 is 6.
Okay.
Then it would be 6.
Uh-huh.
And then it would be 12 plus 48 is 60.
Okay.
And then
You write everything else.
Yeah.
Looking good so far. So 1, 0, 0. Now let's somehow make this a 1.
Okay.
Now, it's up to you, or make this a 0. It doesn't really matter how you want to go. As long as we go 1s and then... So maybe it's easier to make this one 0.
Yeah.
Because I can just do -1 times row 2 plus row 3 and replace row 3.
Can you simplify the bottom there? Because
You
there's
could.
6, 6, 60.
Might as well.
Yeah.
So let's divide everything by 6 on the bottom. So then 1, 1, and 10. And then this one, you actually divide all these by 3, I think.
Yeah.
So this would be 2, 1, and 15. Okay. So do you want to make this 0 or this 1 first?
Make 0.
0 here?
Yeah.
Okay. So
would you multiply the bottom by -2?
Sure, yeah.
Yeah.
So -2 times row 3.
And then add to R2, and then put it in row 3.
Okay.
So it would become 2 should become 0, 0,
Mm-hmm.
and then -2 plus 1 is 1, -1,
-1, yeah.
and then -30, -20.
So -2 times -20 plus 15.
Yeah, 5, -5.
-5. Looks good so far. Okay.
And then put
Place
the
everything
rest.
else, right?
Okay, so now you have to make 2, 1, right?
Yes, if we make this a 1.
Yeah, so what you could do is...
Now, or, I have another idea. To make it easier, we could add 2 and 3 together, and that would make this a 0. Right? And that would make that a -10, and then we could just divide everything by 2.
Oh, okay, yeah.
So let's do that. So let's take row 2 plus row 3
Yeah.
and replace row 2 again.
Yeah.
So let's just recopy this.
Okay, so it becomes 0,
Mm-hmm.
2, 0, 15. Oh, 10.
10, yep.
And then 0, 0, -1, -5.
Perfect.
And
So
then you divide by 2.
there you go. So then you got 1, and you got 5. Boom. And then last thing is to make this 1, just change the signs pretty much. Just divide it by -1. Oh, what was this one again?
That was, I think, yeah, 5.
Okay.
And then
Okay. Okay.
Would you divide by -1 at the top as well?
Well, we want this to be 1.
Yeah.
Now there's still one more thing we can do to make this a 0 if you wanted to also. So you could add row 2 and row 1 together. This would go to 1 and 0 and 0 and 1.
Okay.
Does that make sense?
Yeah.
So once you do that, it would be 1, 0, 0, and 1, 0, 1, 0, and 5, 0, 0, 1, and 5.
Okay.
X equals 1, y equals 5, z equals 5.
Okay.
So this is called reduced row echelon form, or Gauss-Jordan elimination. Have you heard of those before?
No.
Okay. But this is the very most reduced you can get it. You can't get it any more reduced. Notice we actually could have stopped here. We didn't really have to do this last step, because you could have done this. You could have said, okay, I know that 1x minus 1y plus 0z equals -4. I know that y is equal to 5, and I know z is equal to 5. Oh, well, if I know y is 5, I can substitute that in here and solve for x. So you can do a back substitution. You don't have to get these to 0 up here if you don't want to. It just makes it a lot easier, because now you know x, y, and z. Okay. How do you feel about these?
I feel comfortable about these now.
Okay.
Yeah. This is exactly what I wanted to work on.
Okay. Any other questions before we start wrapping up? Okay. Perfect. So you're good with adding and multiplying. Okay.